Right, well, we're very glad to welcome Dr. Benveniste from the Digital Biology Laboratory, Clamart, France, and his colleagues who've come with him to assist. This promises to be a very interesting occasion. I've been learning more about the phenomenon that he appears to have discovered, talking to him today. Of course, most of you will probably have heard of Dr. Benveniste in connection with some publicity, some adverse publicity, I might say, by the journal Nature about 10 years ago, which claimed to have discredited the work. So I have prepared a summary. A brief summary. In fact, what the best source of information about it was a TV documentary series, Heretic, and from that, which gives some of the details that most people haven't heard about. You would see that a rough summary of the situation was that Nature had got reports saying referees saying they couldn't see anything wrong with the experiment, but their attitude was roughly the effect is responsible, so we will come and find out what is wrong with the work. So they sent their investigatory team, totally inexperienced in biological research, and they claimed to reproduce the effect. So they said, aha, without any adequate checks, they postulated a flaw in the experiment, and then using editorial privilege, they published an article called High Dilution Experiment of Delusion. Well, then it transpired that the flaws which Nature considered were explaining the effects away were not actually flaws. The experiment was done double blind, the effects were still there, but Nature didn't allow the original experimenters any proper response, and they then selectively published anything hostile to the work, while ignoring little things like quite a recent event that science magazines had published a libel statement calling the Cavendish fraud. They had to withdraw that because they couldn't produce any evidence in favour of it and had to pay compensation instead. That you would not have read about in Nature. Well, so much for the official word and how it doesn't actually fit the facts very well. Well, one of the things that people who, if you saw that television program a few years ago, saw were, first of all, Benveniste's courageous continuing despite this sort of rather unpleasant situation he found himself in. And in fact, his behaviour as a scientist, here was some indication that there was a very interesting effect. So he went ahead to try and find out what he could about it, and has certainly established certain things about what's going on. Unfortunately, as has been apparent from our discussions, owing to a lack of funding, there have been lots of things that one would have liked to explore which haven't yet been explored, but there seems to be enough to indicate that there's some very interesting phenomenon going on, which might have not only be interesting from the point of view of physics, but it'll also be important from the understanding of what goes on in living systems. But you'll be hearing about that from Dr. Benveniste himself. But I'd just like to, before I give the floor to him, just give some of his biographical details. He got his MD degree at the University of Paris, and was there assistant professor for a few years, and then decided research would be more interesting. So he had a research position then at the University of Paris Hospital. He worked on immunology, something called PATH, which, not being a biologist, I'm not too sure what that means. And then he spent 4 years at the University of California, San Diego, and then returned to Paris, and then worked on conventional work for quite a long time, and then came this work on high dilution, which led to this hostile and unscientific response. This work, his field is allergy research, and it was the means by which he found this phenomenon first. So, pleased to welcome Dr. Benveniste.
INSERM, we have been working a lot since 10 years. Many people think that we are still counting cells on the side and doing our little things. I've been presenting this in congresses, especially in America, because I'm still a member of the American Association of Immunologists, but could never publish anything. And I guess that now things will be reversed for many reasons. C'est arrêté là? Can I get the image? Okay. Okay. Yeah, you saw this one, I guess. That's the only controversial slide I will show. Okay. Now, I wanted to make clear that everything we are going to present, it's not theoretical. It reflects observed phenomena, and there is no revolution at all. It's an evolution of the system, an evolution of the understanding what is going on between two molecules when they talk to each other, which is the basis of all biological phenomena. I don't know what you do, but when I read a mystery book, I always go to the last page so I know the issue, and then I come back to the book, because otherwise I get very nervous. So I'm going to show you the result of the talk. And some who are unhappy with the talk can leave after that. This slide is enough. The current theory of molecular signaling is the following. There is a ligand, a molecule A, that connects through the receptor to the molecule B. And this will trigger a function. This is supposed to work through structural matching, like two teaspoons, one against each other. And this structural matching is supposed to create enough glue for the two molecules to stick together, and enough information for this information to the specific signal to pass on, and then to the next one, and then to the next one, all this in a very quick time. We are absolutely not, as has been printed and said, refusing the idea of molecule existing or the ligand receptor interaction at all. Everything is the same, except that there is no close physical contact. All these molecules are at a few angstroms, like 10, 15, 100 angstroms apart, all the time. It's impossible to have two molecules sticking to each other, if anything, because, as St. Georgi put it once, proteins are a contamination of water. There is 10,000 molecules of water for one molecule of protein. So all proteins are surrounded, except in some spots which are hydrophobic, surrounded by water. Okay, so what we are saying is that between this and this, there is a matching of two waveforms, which probably works through a co-resonating system. And we will show a direct experiment for this, the direct evidence for this. What also we are saying is that the molecule by itself can do nothing. The molecule emits a signal. And the best comparison we have found in the lab is a piano. If you remove the strings from a piano, there is a sound. The music is there, but it's very weak. You won't hear it. If you want to hear the music from the concert hall, you have to have a piano. And the larger the piano is, the best it is to give a concert. So indeed, the molecule, the signal originates from the molecules. But when it comes to reach its target, it has to be amplified by some system. And we have, it's not a theory, we have direct scientific evidence, experimental evidence to show that without the water being informed, the best signal cannot work. Okay, now let's try to go a bit into the systems. So just look at the title. Very, very usual generalities, research patterns, theoretical considerations, and conclusions. Okay. Now, just very quickly to tell you what we have done in between. We had that basophil degranulation of serum anti-Ig. That was the basis of the work in Nature. That was reproduced before publication. And that is against the law. The scientific law says that when you have a result, you publish it, and it is or not confirmed later. But if one asks to all scientific data to be reproduced before, science is dead. So there was, as they put it, special laws for special results. But what I want to say, it's not to go into the controversy, but just to say that there has been 4 labs and 13 researchers signing this paper. And yet people ask me, are the data reproducible? Okay, that was published by Nature. Okay, forget it. In 91, we could show by doing blind experiments with a CNOS team that this activity at high dilution was erased by a magnetic field. And this prompted me in 92 to build an amplifier and transfer in real time the activity biological information to a tube of water. That was, as I'm doing now, speaking in the microphone, the voice is going out of the loudspeaker, but there is no recording. In 95, I just hooked this to a computer. I blew it, the first experiment, because my electronic competence is not that good. But on the second trial, I could record and replay the biological message using a computer. Now we have reached another point where we can activate an apparently inactive solution of water, molecules in water simply by agitating this solution. You will see this result in a minute, or in minutes. So I just will show you some old data. Okay, so the systems we have now we have quite a bunch of systems, like basophil degranulation, isolated guinea pig heart, which is a very sensitive system, which has one problem is that you need to kill animals to do this, so we try not to do it a lot. Human neutrophil activation by PMA. I have been discussing 3 years with the Journal of Immunology to publish a paper on this. All the referees said the paper was okay, but the paper was turned down. And now we have an antigen-antibody precipitation system capable of detecting virtual bacteria. I will show that to you. And also skin test in the guinea pig of the rabbit, which is the equivalent of the basophil degranulation. This is mast cell degranulation in the skin. And now we have a very recent system, which is 2-3 months old, delayed blood coagulation, which works really well, except that we are not specialists in coagulation, but when we set up, it works quite regular. So we have a panel of processes that which can show these results. On this panel, you can work with classical concentration, 10 to minus 4, 10 to minus 7 molar, with very low concentration, down to minus, oh, there is a mistake here, it's minus 15. It's minus 14, just an error, I can see it now, because it works until 14, minus 14, which is very, very low, but by and large stops working at minus 15. We have not seen much at minus 15. So that is the experiment, which is either mixed, slowly agitated, but not big agitation, versus vortex, and I will show that to you. All the same for high dilution, beyond Avogadro's limit. The signal can be applied to a carrier, water, then applied to the sensitive system. Then the signal can be directly applied via an electromagnetic coil to a sensitive organ. Now, you have to, if you want to understand this quickly, to make the analogy with the sound, with a song. The song or the sound can go through a copper wire or to an optical fiber or to a wave or to a piece of plastic or to a tape. The medium doesn't count. What is important is to know that at one point you have either the real voice, like if I turn off my microphone, which is the real molecule in our system, or the electromagnetic counterpart of the molecule. if we can get an electromagnetic counterpart of the molecule, it's because the molecule seems, as far as we can believe our data, to work in the same frequency range, at least. Maybe some other frequency could work, but at least we can have all the effects of the molecule by recording them on a computer with a sound card between 20 and 22 kilohertz. So all this is different way of applying the same system. And in fact, we have some preliminary data showing that even at -6 molar, if the water is not informed, the system doesn't work as well. So by and large, finally, the final end of the molecular signal is an electromagnetic vibration, whether it comes from an artificial source, like ours, a coil, or it comes from the real molecule. At the end, it is always a vibration. So it's a completely unified system. There is no two different way of doing biology. Well, this is no Langendorf. I have just shown that to you. It's a heart here. So you can record the flow of the coronary, or you can record mechanical parameter, whatever it is. These are very old experiments, 91, 92. And just to tell you what we can do with the dilution system, this is the variation in coronary flow, which is by the basis is always 5%. Now, if you add histamine at molar concentration, -7, which is the usual concentration, you get 30% dilation of the coronaries in this system. If you add ovalbumin, the animal has been sensitized to ovalbumin, you get an anaphylactic reaction in the heart, and you get a 50% variation in coronary flow, which is quite a lot. Now, if you take the same two things and dilute them down to log 41, which is 20 logs, about 20 logs below Avogadro, and pool between 31 and 41, you get by and large the same thing. Histamine is non-statistically significant. And this has been done on 77 experiments, not 2 or 3, and probably several hundreds more than we don't compute. And 43 here, 30 here, 37 here, 38 here. So this was routine at that time, but yet we could not publish this data. They were heretics. Now, with the CNRS team, that is the no, sorry, I didn't show you that the CNRS team. That is the step further. That is, with the amplifier, in real time, we would take histamine or valbumin or endotoxin and transfer it immediately to water in real time, then put the water on the heart. And again, these are the controls, and histamine transmitted, which is water. Everything is pure water. Not pure, but water. Naive water, as we say. Okay, do the same job as the real histamine of albumin and endotoxin. When you heat this at 70 degrees, the histamine, it disappears. Histamine can be boiled for days, the real histamine. So it shows that this is not real histamine. It's the ghost of histamine, the mimicry of histamine. But then, same thing you can do with albumin. It's a big molecule. You can filter out of albumin, and you don't have the effect. Whereas this water containing the information flows freely through, and you get the effect at the end. So you have plenty of different systems to check that one is one and the other is the other. Okay, now, mimicking the specific effect of molecular signals, the effect of molecule with computer-recorded signals, and that is the system we are using. I'm not going to go into the detail of this. It's not very interesting. We are applying a white noise to a sample, and then we record the signal modified by the sample, and we put that on the computer. We end with a dot, WAV sound that you can send to the other end of the earth, get it back, and make it work on your system if you want. It's simply a sound wave system. Now, okay, I don't want you to go through all this because it's, we will spend the next night on it, but simply to tell you that, just look at the title, Effect on Isolated Guinea Pig Hearts of the Digitally Recorded Coronary Dilator Drugs. And if you take these numbers, this is beta blocker. You can buy this in the next drugstore. This is also a vasodilator that you can buy in the drugstore. They are used in man. This is a calcium blocker. This is a pharmacological agent dilating vessels, bradykinin. Okay. And as control, this is water digitally recorded. As control here, or the white noise, an EM signal, or water itself. You can see all this is the same. Now, the dilation of the increase in coronary flow is not far from what you find with the real drugs. You can see 20, 25, this one didn't work here, 22, and so on and so forth. So you can mimic a drug that is sold in the drugstore by going there, buy it, put it into water, recording, and play the sound of the drug to the heart. I mean, it's fooling the heart, but you fool your ear when you play Pavarotti or Elton John. I mean, they are not in the room. And they are not in the compact disc either. If you break it, there is no Pavarotti inside of the disc. Well, don't laugh. I mean, don't laugh. The top level of French scientists, you know, which are really the best one in the world because we don't have that many Nobel Prize in France in biology, so there must be the crème de la crème. They keep saying and printing in journals, we need molecules. Physics and chemistry say we need molecules. I mean, physics and chemistry say nothing. They say that physics and chemistry say that that's the way it is. Okay, so they believe that Pavarotti is in the compact disc. So you need Pavarotti to get the sound. That's the way. Now, if you take caffeine now, that could save you a lot of money. You know, you only need to go to the machine. Because caffeine now is doing 15.7%, 0.7, water as usual 5%, and the real caffeine with a good dose is doing 23%. But wait, that's what you are doing to your coronary when you're doing coffee, because this now is decreased. It was increased with the dilator. Now it's decreased. So the molecule, the ghost of the molecule, the imprint of the molecule works in the same direction. When the caffeine contracts, what is recorded contracts too. So we can, simply by looking at the curve, easily distinguish 2 or 3 different types of activator. It's very specific. Indeed, when you play Pavarotti, it doesn't get, Elton John or Aznavour doesn't get out. I mean, that's simple, but you have always to come back to simple comparison to make the people move from the idea that molecules in biology are big chunks hitting each other, and where they are not, they are pieces of vibrating atoms that send specific signals in the low frequency range, which is something we don't understand why, but that's the way it is. Then in '96, I did something which was quite fun. A laboratory in Chicago recorded activities, 24, that were of albumin, big antigen, or water, and sent the 24 activities blind to us, C1, C2, C3, C4, so on and so forth. And we never failed to distinguish one from the other. So they sent it by email. So that was the Lindbergh flight of the molecules. For the first time in August '96, molecules were flying over the Atlantic, and when coming to our lab of albumin, which is a big thing, 40,000 molecular weight, could act all the same as the real molecule. So digital of albumin was 24. And now I realize that it's here. Real of albumin, 10 to the minus 7, was 29%. So you can see we did well as good. And again, that was 30 samples, 58 for the digital water, 4.4 plus 1 is 0.3. And the naive water, just from our lab, without any recording or traveling, was 4.9. This was published as an abstract. I presented at the FASEB meeting in the States. And that's why I got recently a second IG, which stands for ignorant. I mean, it's the jury that is IG, ignorant, Nobel Prize. They quoted that paper. But they didn't discuss it scientifically. When you are a scientist, you cannot say, I disagree, it cannot be, I understand, I do not, therefore it is not. You have to say, I don't agree because of this, because of that, because of this. And I have found nobody who could object to this experiment. Yeah, the only possibility is that the scientist, who is one of the well-known and respectable immunologist in the States at the Northwestern University in Chicago, would be a friend of mine and would send me the code, and instead of doing the experiment, this is frauding. But unless some people comes up and accuse this woman of being a fraudster, which nobody did, obviously they couldn't do anything like that, there is nothing to object to this experiment. She recorded, she sent, and we detected one from the other. Why they considered this is not real? It's because they put their prejudice before scientific evidence. And that is why science, contrary to what is thought biology, is at a standstill. We have no progress in biology. We have progress in technology, but not in biology, since 30 years now, or more. Never mind. That's the way it is. Okay, now, the water is essential in the transmission. And that is something that is really fascinating. Because, in fact, without knowing it, I was working on the basic phenomenon on how the molecular signal is transmitted. I wish I could one day, in my bath, like Archimedes, say, aha, what is the molecular signal? Because you must realize that the two words, molecular signal, are the most used in biology nowadays. You have congresses on molecular signal, lectures everywhere. I'm sure that in Cambridge you have 3, 4, 5 lectures a week on the molecular signal, or people using the word. Then you can do it, it's fun. You go there and you stand in the back, and at the end, you just excuse yourself, say, I don't know anything, I just went in because it was warm here and it's cold outside, and I am a stupid guy. But I hear the word signal, signal, signal. I just want you to tell me, what is the physical nature of your signal? Now, the best answer I got was from Schlesinger, who is the pope of one of these signaling systems. And the answer was in front of a huge audience in the FACEB. It takes a Frenchman to ask such a question. And after I answered, excuse me, nobody's perfect, but could you answer my question? What is the physical nature? This is semantic. Say, no. I want to know what is transmitted between two molecules when you transfer the information from one to the other. I get bad news on the phone. I get white, and my heart is beating in 2 seconds. There has been billions of molecular interaction in between. How do they occur with that molecule finding the other at random? I am adrenaline. I want to find my receptor. Let me try this one. Oh, no, it's histamine receptor. I don't want it. This one, dopamine. Oh, no, that's not the good one. And then there are billions of molecules around competing. And I find immediately my way. How come this can happen with a purely random system, with the molecule not having a way at distance to recognizing each other? There is absolutely no way. So, that is it's not as nice here. Here it's really blue. We call it the nénuphar, par Monet, the water lily. Water lilies, yeah. Okay, now I'm not going to go through all this, but just to tell you, this is acetylcholine here. 10 to the minus 12, acetylcholine doesn't work after 10 to the minus 6 or 7. Mixed in water, here, it gives 44,000 pixels, this dot. And then injected into the skin of an animal which received before a blue dye that is not going out of the vessel unless the vessel becomes leaky. Okay? So it's the equivalent of the test that the allergist doctor do to patients. That it becomes red instead of the rabbit, you inject a dye just to show that there is some leakage. It's a witness for leakage. Okay, this is the tube mixed in water and injected. That is exactly the same tube that has been vortexed 15 seconds. In other words, in classical structural biology, this is impossible to understand. We are witchcrafting, making alchemists making molecules simply by agitation. But in fact, it's not so. Here, you have not enough molecule. 10 to the minus 12, you have 1 10 to the 6 10 to the 8 molecule in your tube. So it's not enough to do the reaction. But when you agitate, it's the whole water that becomes acetylcholine, quote unquote. And then you have a lot of information. This is also a basis to detect compounds of 10 to the minus 12 or 14, which no mass spectrometry can do by this system. Okay, now we block this with atropine. It's here. This is this blocked by atropine. Atropine is the specific inhibitor of acetylcholine. So it is acetylcholine. Now this is a signal. Where is the signal? This is a signal. That is, no, sorry, the signal is here. This is acetylcholine signal that has been imprinted, quote unquote, irradiated from the computer to water. And then the water has been injected. This is a demonstration of two phenomena. One, we can record on the computer. Second, the memory of water is real, because by the time you take the tube and put it on the bench and wait a few hours if you want and inject it to the animal, that tube is water, has never seen any molecule. It's only received a beam and that's what it does. That is the real acetylcholine, 1 microgram. It's not very fair because this is close to the tail and this is close to the head, and the head is more reactive. But, you know, it's about the same thing. And this is atropine with this, showing that atropine does inhibit the reaction. I could show you numbers on this. Acetylcholine 10 to the 12. Diameter this time, 1.6 millimeter. Vortex, the same tube vortex, 12.9, which is 12 millimeter. Now, what is very interesting, if you don't take acetylcholine, but acetate and choline, the two wagon being there, but not hooked one another. So it's not the real molecule, but it's the component of the molecule. And it's the result of the physiological acetylcholinesterase that break open the acetylcholine. Anyhow, mixed, 1.4, vortex, 1.3. You can vortex all you want. If you don't have the activity at the beginning, you won't have any activity. So it's not the vortexing that's doing the job. Now, the real acetylcholine, 1 micromolar, well, this is real too, but the activity is not done by the molecule remaining. It's too scarce. The activity is done by the water. The acetylcholine is giving 18.3, so it's a little bit more, but it's not that much. And, okay, I think I have to go. That is exactly the same on the heart with the calcium ionophore, mixed 4.6, vortex, the same vortex, 23.3, 1 micromolar. On that series, it was higher, 43.2. But you can see that this is very highly significant. Okay, now that is probably, there is a French singer called Georges Brassens, composed beautiful songs. And when you hear a song by Georges Brassens, you have the feeling that the words were created from the beginning to be put together. And that Georges Brassens just copied that first creation. It's so well done. And I always said in my life, I'd like to do one experiment as nice as a Georges Brassens song. And I believe that is the one. It's very pure. And it's very fundamental, not as important, but basic. It's very simple. You take acetylcholine 1 micromolar, or you take ionophore, plenty of compounds. I mean, let's say acetylcholine. But you put it in 100% ethanol. Vortex. It's in 100% ethanol. 10 to the minus 6, very high concentration, very active. You vortex it. Then, only us, we can do this. You record the signal from this compound, from this tube, on the computer. And you get no effect. That's water. Okay, what is missing there? Water. So you remove 20% of ethanol, and you add 20% water. But you mix only. The molecule is there, the water is there is some ethanol around, but, okay, you record nothing. Very little less, but not significant. Then you simply vortex 15 seconds the whole thing. And here you are. It tells that not only the water must be there, but with some phenomenon, with some energy, maybe the cavitation, though this water has to get in close contact with the molecule, since I don't know the basis, and nobody knows the physical basis of this ability of water to transfer this, I can say anything. It's not a problem. I could say, for example, that if you speak into a microphone, I put that microphone at 1 meter, you won't hear me. And really, I have to agitate the microphone to bring it. But that's just a comparison. It's not at all an explanation. Anyhow, this experiment is really perfect. And once you have the necessary equipment to record things, everybody can do it. I mean, it's so simple. But it tells you how important is the water from the transmission of... in other words, the molecules are there, there is water, but the molecule cannot express... It's like the piano string. There are not enough energy for them to really be able to stimulate the whole thing. I like it. You understood I was in love with this experiment. I'm going to divorce and marry this experiment one of these days. Okay. Now, a little more fun now. Now it's an antigen-antibody precipitation system. And it's fun, not only because it's a good experiment, but also it's applicable to a lot of things in real life. And even if people were not as, what the word I could use, I don't want to say stupid because it's not a question of stupidity. Close-minded, yeah. They would make a lot of money with this. And also solve a few problems in health, if this interests anybody. So, you've got bacteria. Let's say you've got E. coli in your tube, and you record this signal. You must be remembered that we are able to record whole serum from a goat, for example. It's as if you record the Philharmonic Orchestra, for example. Because in serum you have thousands of compounds, and each of them billions of molecules. Now, if this serum is an anti-rat IgE, the immunoglobulin of the allergy, it's, I don't know what it is, but it's probably 0.0001% of the total amount of junk that is in the serum. That is the immunoglobulin IgG anti-IgE, very small amount. Yet, you record that, you add this serum to the heart, and the heart will undergo anaphylaxis. If you record the anti-IgG from a goat too, same kind of serum, the rat heart will do nothing because anti-IgG does not trigger. So you will say, oh, that's fantastic, your system is very sensitive and will really pick up that two notes at the end of on the right up in the orchestra, the triangle that will do ding, 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 and then it will pick it up among the whole, symphony. But, you know, when you inject a serum to somebody, let's say somebody is ill, who you want to inject a serum against tetanus or whatever, in the old time, you inject the whole gimmick, the whole thing is injected. And the receptor has to find the good antibody, quote unquote, among all this noise. It's the same. So when we send the signal, we send a whole bunch of activities, and the signal finds its way to the receptor. So again, there is nothing different. So it's not surprising to us that we can record a bacteria. The bacteria has a lot of protein, but among these proteins, some of them are antigenic and are recognized by an antibody. And if this bacteria is among millions of other bacteria, the antibody will find these bacteria that it is specific to. All the noise around is regardless. But when you phone on your portable phone, there are thousands, if not millions, of waves going back and TV, radio, whatever you don't care because it's not tuned on your own frequency when you are talking. So this noise is totally irrelevant. Whereas it's not irrelevant to the next guy who is talking on his phone with using this noise, which is noise for you, but it's a good frequency for him. Same thing. Horror. Okay. So we digitize it and store on a computer the bacterial signal, and then you apply to a biological system sensitive to this specific signal. The signal can, like any computer file, be sent great distances. This means that if it works, we can detect a bacteria at 10,000 kilometers or from another planet, as long as the radio will send the file to us. And these results are really, really nice because we have a system that is precipitation, which is an agglutinating system, which is rather old but still sold. I mean, you can see them working in day-to-day life in any clinical lab in your country and in mine. In fact, a British firm just put out an AIDS test based on this agglutination technique because it's much easier to use in undeveloped countries than the cumbersome radio stuff and fluorescent and whatever you that we have here. Okay, so you have a detection system that you decided to take out of the shell, which detects E. coli. And you add to this E. coli system a transmitted signal, which is Streptococcus, which is not recognized by the system. And you do have this kind of thing on the microscope, and the computer will analyze this and give you an aggregation index of 30. You can see that there were a lot of small aggregates. That's the size of the aggregate. You cannot see this. And that is the number of aggregates. So there are a lot of small ones and practically nothing after the arbitrary limit of 100. Now, if you add transmitted signal E. coli to the system, there is no way to focus this. Or is it me or is it on focus? Yeah? Okay, well, yeah, I'm too close. You can see that the picture is completely different. Then that is the real signal, and the signal has increased the precipitation, specifically increased the precipitation of the E. coli. And therefore, if you have a lot of signals coming from an ice factory in Kuala Lumpur to your lab in Washington or in London or in Paris, you can analyze all these signals and put them, and then if one of them gets out, say, oh, there is E. coli in this ice cream batch. No way, no problem at all. And this is transferred from Kuala Lumpur to your lab in a matter of seconds, and also is permanently recorded. You can come back 25 years later, and then you found a new bug that was not known at the time, and you come back to your thing. The other one is Streptococcus this time. You add Streptococcus, and then transmitted signal is controlled. It can be water, E. coli, whatever you. So again, you have little aggregation, 50, 52, all of them on the left side. And here you start the Streptococcus. Here you have a good reaction with a hugely different index. And as you can see, little is left here on the small side, and you have big chunks here, which are those here until 500, I think. That's 500. Okay, so what does it mean? Does it mean you can detect anybody, any antibody, or any antigen here, but also any antibody? Because here we put the antibody as a detecting system, so we detect the antigen. If you put the antigen, you detect the antibody. So you can detect anything. For example, if you have a good antibody against prions, you could detect prions on the head of the cow or on your head. If you have a sensitive microphone, you pick up the signal of the prions, then you add here, and you can do it. You can pick up a foreign protein that is a, we say here, GMO, genetically modified organism, in the plate of the consumer at 10 to the minus 14 molar level on the telephone. I mean, this is the basic principle. It's an antigen-antibody reaction. So anything that can be can give rise to an antibody can be detected by this system. So you can see the immense opening of this technique. You could believe that, for example, when you go to a disco at Saturday night, you put, now I'm joking, but never mind, we have to joke a bit, and you put your finger into a hole, then the machine will do the analysis, then you will have a piece of paper, and then you can show that around and say, oh, I have no hepatitis C, I have nothing, and then you can interact with the opposite or the same sex according to your taste. Safely. Okay. Well, in fact, it's a good idea. And I'm going to make a lot of money with this. Don't you think so? Okay. Good. Let's go. Okay. Now, yeah, as a bonus, you are allowed to see my face. Sorry. Not well shaped. What is this? This is a tube that contains a liquid which is plasma, human or rabbit plasma. And it's flowing. This one contains plasma that is clotted here. It's not flowing. What's the difference? You take, when you draw blood on anticoagulant, and that removes the calcium. It's a calcium chelating agent. So without calcium, the blood cannot coagulate. If you add calcium to the blood, it will coagulate. But if you add calcium plus heparin, which is another anticoagulant, it will not coagulate. So here, we had a blood, a plasma, that we can keep in the refrigerator for days and weeks. So we just remove the plasma from the refrigerator. We can bring it here, or send it here by mail, and we put it in a tube, and you add calcium to it, and it clots. And on another series of tubes, you add heparin. It doesn't clot. Except that this heparin is no heparin at all. It's recorded on a computer. So it shows that we can now have a very easy to do detecting test that can detect high dilution, because now I think I'm going to show this, so I won't say that. Let me go further. Now, this can be done also in a reverse way, because let's say that you have a blood that is anticoagulated, like here, with calcium. Now, here you add calcium. No, so yeah, here you add calcium, it's clotted. Here you add magnesium, does nothing. It's very close to calcium, magnesium, but it doesn't act on coagulation. Except that this is no calcium at all. This is virtual calcium, recorded on a computer. And this is at the third system where we have seen the virtual calcium working. It works also on isolated heart. And is it witchcrafting? No. When heparin goes to the site where it is supposed to go to block the coagulation, heparin has no fists to punch the other guy on the nose. It has no fingers to tickle the other molecule, so it would jiggle so much they can do its work. I mean, all this is ridiculous. I mean, there is no way a molecule can interact with another molecule by mere physical force. The contact theory, the théorie des chocs, was proposed by Descartes in the 17th century and shown immediately by Huygens to be wrong. And you know that the main controversy, I'm not Descartes and much less Newton. There are many reasons why I'm not Newton, is that first I don't speak good English, and second he was very rich. He was very beautiful, and as far as I understand, he was a virgin when he died, which I have none of these characteristics. Sorry to say that. But Descartes never talked to Newton. Anybody saying that a celestial body can interact with another one without a physical link was back to obscurantism. And that was said to me on the Channel 4 TV in 1989 by a guy in this country called, what, John Lewis, or something like that? A doctor, MD, which is also well-known in the theater system. I can't remember his name. Jonathan? Jonathan Miller. Yeah. And he said to me, even if you are right, we want you to be wrong. Because if you are right, all the astrology, numerology, homeopathy, whatever, you will come behind you. I said, wait a minute. I mean, you know, Newton described the law of gravitation, and is he responsible when a nuts from a hooligan from Manchester knocks down a hooligan from whatever Newcastle. I mean, you know, that's football. If you kick a ball, it's going to go up and it will go down. That's not Newton's fault. If I have found by serendipity and by luck a main system that is instrumental in molecular communication, if some people have been using that empirically for 200 years, I wasn't there. So please blame the guy, blame Hahnemann, you blame who you want, but I just done my job. But that is the way that how ideology can surround science now, and where the consequence of a result is more important than the result itself, which is against the scientific way for science to progress. A result is a result is a result. If it's important, fine. If it's not, it's the same result. I went into the controversy again. So, you can test heparin, which is sort of heparin. It's an anticoagulant. And you can, if you vortex water, the mean time of clotting of your blood will be about this. If you mix iridine, like this, minus 12, you have the same by and large here. If you vortex iridine, you have this kind of mean increase. And that is done in a system that is not the best we have. Again, it's another distortion. We cannot export the system the best we have. Why? Because it's rabbit blood. And here in this country, in America, in Germany, in Switzerland, you have to go through the court to be able to from a rabbit. I mean, you know, you can take all the blood you want from kids, especially if they are from a very far country outside of Europe, but that's no problem at all. But if you take 1 millimeter of blood without a rabbit, and somebody answered to me seriously, the main difference is that man can say yes and the rabbit cannot. So it's such a system where we cannot have those experiments easily reproduced, especially that biologists don't want to do it because of the nature thing. So it is the snake that's biting its own tail, and we are going around like that. So we do that on human blood, frozen, human plasma, frozen and kept into the refrigerator. You can get this from your blood bank, especially when it's out of date. They just throw it away. So you get it, and you do this kind of experiment. It's free, and nobody will object to it. So when you vortex it, the mean increase of coagulation time between this and this is 37, 18, 38, 43, 33. In rabbit blood, we have had experiments where on Friday night, the iridine was not, the virtual iridine tube was not clotted, and it was yet not clotted on Monday morning. So it was definitively blocked simply by a virtual iridine. And now I am going to make a big scandal. The riddle of homeopathy can be solved in half an hour. They have been screaming at each other. Homeopathy cannot work because, and I'm not an homeopath. I don't care at all about homeopathy. It's not my, I'm a hugely classical doctor. I was doing intensive care in cancer patients. So, you know, very far from homeopathy when I was acting as an MD. But I must say that when I go to the drugstore and I buy as a control Nux vomica and then heparinum, and I check for the activity of heparinum, you can see that there is a huge difference in them. That's the mean increase plus 1 SD on 29 experiments. It's 25.7% difference. Again, on a system which is not very sensitive. In other words, if these people were not ideologically constrained, they would come to my lab, or they will accept what we are going to put on our website, which is a do-it-yourself experiment. They will drop 2 granules per ml into water, wait for the granule to dissolve, put that on the plasma tube, add some calcium. As a control, they will use Nux vomica, they will see the difference. One of them will be fluid at one time, the other one will be clotted. And the whole riddle about homeopathy is closed. What homeopathy is by and large a compact disc. That's it. Now, I'm not saying that clinically is working. This I don't know, because you have to do clinical, you know, it's not because aspirin cure your headache that is going to cure cancer. That's a totally different thing. But the basic principle of homeopathy is obviously working. And here is one of the data we have. We have many others. Well, again, you can digitally record also. All this were due with agitation or with the granules. Now it's a digital recording of hirudin. And also you can record the hirudin from the granules because it's the same. You can record your voice from your voice and also from a tape where your voice is. It's the same. It's always a vibration, a frequency. I don't like the word vibration, but a set of frequencies, a spectrum of frequency, as my collaborator Didier will tell me. It's not frequencies, it's spectrum of frequency. I don't know the difference, but never mind. It's not my problem. Okay, so here you have, again, water recorded. Here you are. Hirudin recorded. Here you are. And the mean is 35%. This tube had a 96% increase over water, simply by a beam of the anticoagulant put into water. Just to tell you quickly, we have done this experiment in 3 rabbits. That's all. So it might be very preliminary. But we have put a digital hirudin or heparin under the tongue of 3 rabbits, and for 15 minutes they could not coagulate. So that's the prototype of what will be in the future the digital medicine, where we will not use the drug by themselves, but the information of the drug. When we have increased enormously our system, this, what I'm presenting to you, is the Antoinette of Louis Berriot when he crossed the Channel as compared to the 747. No, sorry, to the Airbus. It's very primitive, but it shows that a heavier than air can fly. Okay, I think I'm at the end. So now you understand why I keep saying it is the same thing, except that we don't use the arrow. The arrow is fantastic for biologists. You know, an engineer put an arrow. The Airbus goes from Paris and then to Heathrow. And to summarize that on a slide, you put an arrow. But the arrow means that you know everything about the Airbus, the engine, everything. You built it yourself. So it is a symbol of everything you know about the machine. The biologists use the arrow instead. The molecule A is going into the cell, for example, protein kinase C. You activate the cell, will go from the nucleus to the membrane. And they call it translocation, which is a fantastic word, which means movement. Yeah. But movement is ridiculous because if you ask your taxi driver, this thing is moving, it will actually, how? What is the engine? What is the steering wheel? What is the brake? If you use translocation, the taxi driver keeps shut, his mouth shut, cannot answer anything because it's too important. But same thing. They use the arrow. I use the arrow instead of knowing. They have no idea how those molecules, and when you ask the question how they work, they give you pictures, phenomenology. I remove something here and I add something here, so it does this and the result is that. But yet they have no idea how it works really in physical terms. So that's all it is. We replace an arrow by a wave. There is no reason why we should be guillotined by doing that. I mean, okay, so the conclusion is high dilutions share the same mechanism with usual molecular reactions. The triggering molecular signal is carried by water to the target whether or not the source substance is still present. It's always the same thing. If you want something for the music, always carried by the air, whether or not Pavarotti is in the room or not. The same thing. So what have we shown? We have shown that we can trigger biological effects with low frequencies electromagnetic signals. These biological signals are carried, transmitted with water. Thus, we invite you, the pros and the cons, that's a bad French word, but in English it's okay, to examine the protocols and replicate the experiments by yourself. I think that's it. Yeah, it's a conclusion. Why is it so difficult to be accepted by the system? And to this question, I have still no answer. Thank you. Yeah, sure. If you have any time, any patience left, I'm ready to answer your questions. I think there is one here. There's one here.
Yes.
The signals you're talking about, I'm a bit confused. Did you say they're sound waves or electromagnetic waves?
No, they are picked up by electromagnetic coils.
Okay.
So I'm always making the analogy with sound waves. But they are picked up by magnetic coils. They are recorded on a computer, which doesn't record sound as such, but record the electromagnetic counterpart of the sound. And they are diffused by a coil. So they are electromagnetic. I'm just making an analogy with the music. And they are carried by water, like the sound is carried by gas molecules.
What do these signals actually look like? I mean, if you analyze whatever you
It looks like a huge bunch of noise. There is, we are, given the huge amount of resources, financial that we have, but we use it only to buy expensive British cars. So we cannot devote all this amount of money to buying decent equipment. So we are recording with this kind of computer, which is fine for Elton John, but not very fine to reach the amount of bits, like 20 bits or something that we should use. He's here, Didier, who is doing the job, is here, who could explain that to you much better. But the fact is that when you when you record water without anything in it, you have a spectrum, frequency. And you record another water, or the same water 2 minutes later, and you have another spectrum, because you record the noise. And over this difference in spectrum, the real effect of the molecule doesn't seem, given the current level of our technique, to make any difference. So we have to deal with people specialized in sound analysis who have a very, very expensive equipment that we cannot afford.
I don't know whether there is a statute of limitations in science, but I must admit to having been one of the referees of your paper in 1984, which led to a lot of vitriolic correspondence with the editor of Nature. What I don't understand is why is water unique here? Everything that you've told us, reactions can also be performed in other media. For instance, sound will be carried by carbon dioxide or by nitrogen. And there. And so there's nothing here that I can see that if you were to translate this into chemical reactions, you could not equally well do in another liquid.
Yes, I mean, you are pointed out to our limits. What I can tell you is that I tried pure ethanol, which is also a polar liquid and doesn't do the job. Propanol, but we have not tried much. My gut feeling is that only water will do the job, but it's simply a gut feeling.
Can I just answer that as a physicist? Well, not completely answer it, but the simple point is different substances are different, and in fact water is unusual in many ways. So I see you shake your head, but it is a fact. Some substances superconduct, some don't, some insulate and some don't. And so I think we have to accept that.
Yeah, furthermore, really, at the point where we are now, our goal is to make, through publication in the high-level journal, people understand that the results are real and that they can start working with them. So we are not going to, we have already done in 10 years more than we should with 4 or 5 different biological systems and a lot of progress, but we are not going to try this in all pharmacological systems, and we leave that water problem, which is a fundamental problem about physique de la matière, I mean, matter physics, I don't know the word in English, to leave that to the physicists. Now, if they tell us that, okay, you take that liquid which is very weird and it has all the characteristics should do the job, then they will send that to us and we will be able. Furthermore, before I had the computer signal, I could only inject water into my system. And otherwise, if you inject anything else, you kill the heart or you kill the cell. Now I can indeed analyze what's going out of any weird liquid and see if the signal is there. But up to now, I could not do it.
Surely this isn't so surprising. It's all biological systems, water-based, and all the test materials are biological.
Yeah, but you can also think that, for example, if the biological system had evolved in ethanol, which is not that different from water, we would all be based in ethanol and would be drunk by drinking water. Why not?
Two questions, one short one and one long one. Short one is, have you tried deuterated water? What happens?
Ah, boy. I mean, this question has been asked to me repeatedly, days and days, and every week, I take about one shower a month because it's a nice place to relax and think. And every time I take a shower, I said, I have to do next week the treated water. And it's simply the fact we are running all the time and we are doing this. This should be done, I agree with you. It's ridiculous we have not done it, but I don't have the answer.
And the long question is, over the last 100 years, really, starting from Paul Early with his ideas of serum and anti-serum, biology has accumulated a huge body of evidence, indirect and later becoming quite direct with the advent of X-ray crystallography and mass spectroscopy, that biological molecules need to bind the receptors to act. Are you trying to say that all that is rubbish?
I thought I showed the contrary. Same system with the same binding. And when you say binding, I could answer, what is the glue? You say bind, affinity constant. That's just, saying that it sticks harder than other molecules. But what is the glue? But never mind, let's drop the glue system. But when you say bind, you mean being in close contact at 50 angstrom with a lot of what?
Physical contact.
Yeah, the physical contact. Physical contact is 50 angstrom.
No, they are in close proximity, as X-ray crystallography shows, that they're in very close proximity. Nuclear Oberhauser effect acts within a very short distance.
Okay, I mean,
Well,
I don't know what's happening in real life. I mean, if you take a molecule like an antigen bound to an antibody and then put it under X-ray crystallography, it might at that time be in close contact, showing that indeed it was in close contact. But the hypothesis we have is that in real life, when it's circulating in the blood or in a cell, this thing stands with a few layers of water in between, which is not much. And
NMR experiments can show
okay, they are in contact. Okay, well, this has to be discussed. Anyhow, to us, the best comparison I can have is that when you listen to your telephone, it's close to your ear, otherwise you listen nothing. So those molecules have to be brought together to be able to send this very weak signal. It's not amplified like we do with this computer. When we record with the computer and replay the signal as such, we see nothing. That's something I forgot to say. You have to amplify it enormously because it is not in that close vicinity where a weak signal can be felt by the. So
I just say it's quite common in science for all experiments up to date T0 to show X is the case, while experiments after T0 show something different is the case. So I don't feel that's such a strong argument.
You need contact to have the thing. And the question can be returned. Okay, they are in contact. They are in close contact. You realize that the drug designing drugs against molecules by the same shape, it has little success up to now. Maybe we found 2 molecules in 15 years after a few $1 billion of that. Because the shape is not enough. The shape is better.
Being too dismissive about structural similarity. After all, it was started with antihistamines by...
No, I'm not dismissive at all.
There are lots of drugs that are designed by structural similarity.
Not a lot.
It's not just 2 drugs over the few
Not a lot. It's cimetidine designed from the knowledge of the structure of the molecule. Is cimetidine another one, which is nice. But I dismiss nothing. I agree entirely that if 2 molecules are in close contact and have the same shape, you have better chance for that signal to be identical. But you know as well as I do that if you take one of these molecules, big or small, you change a phosphorus and you add a sulfur, it doesn't work anymore. And you do not change, especially when you have let's take an antibody, for example. An antibody is 150,000 molecular weight. You switch two amino acids at the end. The specificity is completely different. There is no way to explain that in structural terms. Absolutely no way.
There is.
Well, okay, but
Well, I'll come with that.
yeah.
I think you're too dismissive of the structural biological data. That's what
I'm not dismissive at all. I simply say that between those two molecules, whether or not they are similar, in close contact or not, the only way for this molecule to communicate is an electromagnetic wave. Because if I am dismissive, I can return the question and say, what do you propose as a mean of communication specific, a mean of recognition at a distance? Because again, the adrenaline, when it finds its receptor, cannot find it at random. Because when you say they are in close contact, what you are saying essentially is that the plane has landed on the strip. But what brought the plane to the strip? At that time, they are not in close contact. They are very far away. And the adrenaline receptor has to find very quickly its receptor. So we believe there is some electromagnetic, explained by some quantum physicists, which I cannot go into because I have not enough knowledge, of long-distance interaction that are going through quantum electrodynamics. Well, you believe it's not. I believe it's the way. It remains that the basic fact is there. When we record these molecules, we can get all the activity of the molecule by itself. So I don't see why nature would have provided these specific frequencies for us to play with and use another system to communicate. I believe that it is the same system and that molecules communicate via this system. We are in controversy. It's only the future will tell.
Well, I'm sorry for all the people who wanted to ask questions, but time is getting on, so I think I have to leave the discussion, bring a discussion to a halt now. I think these are important scientific issues, and if the issues are to be discussed scientifically, it's essential that people should look at the experimental data, and it seems that there is data for people to try and that needs to be looked at. I'm rather reminded by this whole affair of a statement that a certain politician by the name of Thatcher made some years ago, which was, "It's a funny old world." It's a very strange situation we seem to have in science, where there's a kind of power situation. What's happened is partly a manifestation of a power situation where if a result is sufficiently unusual, it is just ignored despite the evidence. And I'm glad that this work has continued, and I hope some people will take up the challenge of looking into these phenomena and seeing what they tell us about science. And I think there are challenges for us physicists as well as for experimenters looking at these. So I'd like to thank you very much, Dr. Benveniste, for coming and giving us
just a little to follow this discussion. It's not a challenge, because a challenge means that the two parties have equal rights to express themselves. Now, if you want to publish any new result on the structural matching of protein, and if it's a good result, you'll have it published in Nature. If you say, yes, that's fine, but in between there is a electromagnetic information, then the paper will be turned down immediately. There is no more space in Nature. So that is the main problem, that there is no way for equal discussion like it was in the 1920s, where science was open and there were no big institutions like that. The big institutions now are crushing the possibility of science to move forward. We must realize that.
So
I don't say more.
let's hope.